In this video, we will be doing the priority based processing for our notification system. Priority based notification का मीनिंग ये है कि अगर if there are multiple requests in the queue जिनकी अलग अलग प्रायोरिटी है, so the order of processing should be based on the priority field. मतलब for example, if there is OTP and some promotional message, then we want to give or give more priority to OTP, right? And we want to process it as fast as possible. हम उसमें delay नहीं करना चाहते. Whereas if it's promotional, then we can delay it. So we have to add that support. Right now in the last video what we have done is we have moved from synchronous behavior to asynchronous behavior by introducing a queue. कि क्या हो रहा है कि अब जो मेन थ्रेड है इट इज एडिंग दीज नोटिफिकेशंस टू सम क्यू एंड देन दिस we have also created multiple workers which are consuming from these queue and then calling the vendor APIs to do the work. But ये जो consumption वाला जो पार्ट हो रहा है it is happening in FIFO. ठीक है, जैसे जिस ऑर्डर में इंसर्ट हुआ उस हिसाब से वो पोल हो रहे हैं. We don't want to do that. फॉर प्रायोरिटी बेस्ड वो जो पोलिंग है राइट, पोलिंग शुड हैपन बेस्ड ऑन प्रायोरिटी. अगर मैं कोई वर्कर है अगर वो पोल करे, इट शुड गेट द हाईएस्ट प्रायोरिटी एलिमेंट एवरी टाइम, जस्ट लाइक हीप. इमेजिन दिस इज अ मैक्स हीप जैसा कोई प्रायोरिटी कोई हमको क्यू चाहिए. एंड सो एंड द सोल्यूशन इज सिंपल. द सोल्यूशन विल ओनली टेक मैक्स 4 to 6 minutes. But before that let's just understand in a single minute about in on whiteboard कि हम करने क्या वाले हैं. So if you can see my screen. तो अभी प्रॉब्लम क्या है, अभी हमारी जो क्यू है, द क्यू राइट नाउ, दिस इज आवर क्यू राइट, एंड we created some workers here, right? Worker 1, worker 2, worker 3, and this is our main thread. It was enqueuing the notifications, right? तो अभी ये जो पोल हो रहा है राइट, इट इज हैपनिंग इन FIFO. सो जो नोटिफिकेशंस है राइट, दीज आर गोइंग लाइक दिस. सो इमेजिन N1, N2, N3, N4 ऐसे इंसर्ट हुआ है राइट. दिस इज द ऑर्डर. सो फर्स्ट दिस विल बी कंज्यूम्ड, देन दिस वन, देन दिस वन, देन दिस वन. ये प्रॉब्लम है राइट. वी डोंट वांट टू डू दिस. रादर वी वांट टू डू इज वी वांट टू डू प्रायोरिटी बेस्ड पोलिंग. And how to do that? The solution is simple. Solution is convert the queue into priority queue. Simple. आप ऐसी क्यू यूज करो जो प्रायोरिटी सपोर्ट करती है. एंड व्हाट इज दैट क्यू कॉल्ड? प्रायोरिटी क्यू. अब प्रायोरिटी क्यू में व्हाट इज द रिक्वायरमेंट? सो प्रायोरिटी क्यू का रिक्वायरमेंट होता है, प्रायोरिटी क्यू के अंदर जो भी नोड्स होते हैं राइट, जैसे हमारा नोड क्या है, नोटिफिकेशन है, तो जो नोड है ना इट शुड बी कंपेरेबल. मतलब इट द क्यू शुड नो और द JVM शुड नो हाउ टू कंपेयर टू नोटिफिकेशन. जैसे अगर नोटिफिकेशन N1 और N2 है, अब कैसे पता करें कि इसकी प्रायोरिटी ज़्यादा है या इसकी प्रायोरिटी ज़्यादा है? सो वी हैव टू इन ऑर्डर टू do this distinction, right? In order to decide whether which one is of higher priority, we have two options. Either we implement comparable or we implement a comparator. Both are interfaces. अगर आप ये implement कर दोगे, implement करने का मतलब क्या है कि हम बता देते हैं कि how to differentiate between two, basically how to compare two different objects of type notification. इसका हम implementation इससे दे देंगे. So we have to do this and we have to use priority queue. Simple. So this is the only two steps that we need to do, and our problem will be solved. So let's move to the ID and do the implementation. So first thing is I'll update the queue. So where was our queue? If I go to the implementation of queue, so right now we are using I think I've already updated it. Okay, it's fine. So earlier it was linked blocking queue. It was like this, or let me just undo it to show what was earlier. If you can see, this was the piece of code earlier. Okay, it was using blocking queue and the implementation was linked blocking queue. Now what we'll do is instead of blocking queue we will use priority blocking queue, and the implementation will also be priority blocking queue. Only this much change is required at the queue level. This itself has converted the queue into like supporting priority. Now the problem is right now जो notification है, it is not the queue does not know how to compare two notifications, like किसकी priority ज़्यादा है. Okay, of course we know that there is this priority, but JVM does not know, right, that if it has to use this field to compare. So उसका solution क्या है? Either we implement comparable interface or comparator. For now what we'll do, we'll implement the comparable interface. So what we'll do, implements comparable, and like there is a standard way how to implement, और इसमें क्या करना पड़ता है, we have to implement the compare to method. There is a compare to method that we have to implement, and the method is very simple, right? Compare to का मतलब, if I have to convert, if I have to compare this particular object with some other notification object, how do I decide, how do I compare? So that logic we will write here. So the logic is int diff equal to this dot, we have to use priority, right? So this dot priority dot level dot get level dot compare, just one second, dot compare. Okay, so I can use the integers compare method. So I will compare my get level, like my level, versus the level of the notification, which is, let me write other, let me name is other. So other dot priority dot get value, get level, simple. And if this difference is 0, well, if they are same, then basically that means they have same priority. If there is same priority, then we will decide by some other parameter. So we can decide by created at. So we used, then we compared created at. Otherwise we'll just return this diff. Done. We have given the implementation of comparable. Like now we know, now the JVM knows how to compare two notification objects. So we have converted the queue, we have also added the comparable interface. The work is done. Let's just see the demo. So if I, so earlier we were sending a single request, right? Now what we'll do is, I have created 3 requests. Okay, I have created 3 requests, and you can see the priority also. One is high, the other is medium, the third is low. And let me do one thing. Let me do the insertion, or let me revert the insertion order. 3, 2, and 1. So I am inserting the low one first into the queue, then the second one, and then the third one. Like the first one I'm inserting at the last, which has higher priority. So if I was using FIFO queue, then this third one, the priority, which one, the notification which is of low priority, it will get processed, then the medium one, and then the high one. But now since we are using priority based, the order will be different. The order will be, the high will be treated first, then medium, and then low. It doesn't matter what was the insertion order. So now there is a problem to simulate this. Since the workers are spawned even before the worker gets created here, right, in the constructor of notification service. That means at this point of time the 5 workers are already ready. So when we come here and when we try to add the first message itself, it will get immediately picked because it does not have messages to compare, right? So as soon as the first one will enter, the consumers will pick it. So we will not be able to show, right, whether if it's working correctly or not based on priority. So what we'll do is, we will stop the workers and we will start the workers only after we have inserted into the queue. Okay, so how to do that is, we will remove this like worker creation part from constructor, and rather we'll create a method. We'll say start worker threads. Okay, and we'll just paste it here. And this, we have to do one more thing. Let's also reduce the number of workers to 1. So why 1? Because let's say if you have four workers, now all of them will try to poll, and they will be able to get different, they will be able to consume all together at once. In that way also we will not be able to differentiate, right? Like it's possible. See, with threading, that is the thing, you can never predict the execution order. That's a problem. So that's why I'm using a single worker, so that we can see that if it is working correctly or not. Okay, this is just to show evidence, not to like, no, I'm not writing like wrong code just to show if it's correct or not, but this is just to show evidence. So I have added 3 elements into the queue, and in the reverse order. So I'm inserting the low one first, then the medium, then the high, and then I'm starting the workers. And so if I execute, let's see what happens. I hope it works correctly. Let's see. So messages were added here. The important thing is this. Okay, yeah, see this. Worker consumed message priority 1, priority 5, priority 10. So which one got consumed first? Priority 1, then the priority 5, then the priority 10. So look carefully, see. What was priority 1, by the way? For which priority did we assign value 1? If you go back to the notification, let's just see. Yeah, one was low, so so the reverse happened. Low is being treated first. That simply means the way we are comparing is reverse. It is actually it is considering, it is giving higher priority to the lower number. So what we can do here, the answer is simple. What we can do is we can just reverse this. We can just reverse the order. So instead of this, let's let's reverse this. And similarly here, let me just, okay, now let's execute again. We'll stop the workers. So what has happened now, it is although working on priority, but the order is different. Now let's see what happens. See now, priority 10 got fixed first, then priority 5, then priority 1, although the insertion order was different. So it is working correctly. You also got the point, right? Why it was not working correctly earlier, because the way we have implemented compare to was wrong. Like it was basically ordering them or comparing them in the ascending order. Okay, instead what we wanted is we wanted it to give us the descending order comparison. So that's why I just switched the places, and now it's working. Let's just go to the service again and see how everything is playing out. We'll just recap. So our notation service now has factory and a queue, right? And we introduced start worker methods, which basically instantiates a manager, and the manager is spawning these threads. How it is doing? Let's go to the worker manager. See what it is doing. It is creating an executor service, and it is instantiating the workers. How many workers it is creating? The number of workers that we are passing. So it will be creating that and then submitting to the service. After that, what we have done is inside the send notification, you can see any request that is coming, it is just being pushed to the queue. See, the main thread is only doing one thing. It is just sending the message to the basically the notification to the queue, and finishing the operation. And after it is submitting to the queue, it is the worker's job to poll and do the work. How is that happening? Let's just see the code again. Let's go to the worker. Let's see any worker. This is the notification worker, which is basically a runnable. That means it's a thread. And what it is doing, if you see the run method, it is just, it has a while loop, and it is polling the queue. So it has the reference of the original queue. It is polling that queue, and whatever notification it gets, it gets the channel from that notification, and from the channel it uses that channel to get the actual instance of the SMS, like the notification sender, from this factory. And once we get the concrete implementation, we are able to call the send method. And we have added the implementations, right, like SMS sender, email sender. So this is the complete scalable, and like we have covered almost all the requirements, and we have tried to follow solids. And I hope you have understood this. If you have any doubts, please comment. If you want me to create some more videos, please add comments and subscribe. I hope you have learned. I will be also adding the coding link in the description. So stay tuned and happy learning. Thank you.